Everybody. Just wanted to give you a brief rundown on the multicast API from within Java. This is from Chapter 29 of the Java for Programmers book. First, what's multicasting? Well, we're familiar with sockets at this point. We know how to open up a connection to a specific IP address with a specific port and make a unicast transmission occur between a connection that consists of a client and a server. But we'd like to know, what is a multicast socket? And the answer there is it's connectionless. We're using UDP IP instead of TCP IP. So a unicast socket provides a point-to-point connection. It gives us a pipe with data that comes in at the same order, in the same order that it goes out in. So what we'd like to know is what other options are there, and multicast gives us the ability to broadcast out onto a local area network and then traverse the routers. And we have a special tag for that called time to live, which allows us to determine how many hops a router will allow us to make before we're killed, so we don't flood the internet with our packets. So a packet could go perhaps as many as 3 hops through compatible routers in order to be able to reach all of the local area network computers within a certain range of our LAN. So why doesn't everyone use multicast? And the answer is, well, not all routers pass multicast sockets. You've got to configure it. Multicast might not be supported on your network, especially if you're in an environment that's got administered smart switches. The time to live packet parameter allows you to determine the maximum number of routers a packet can traverse. So what do you need it for? And the answer is, well, you can use it for broadcast if you want to do plug and play devices such as printers. So it's very good for discovery. It's good for broadcast. It's good for things that allow network legs to permit, if you will, the multicast traffic. An ether switch typically will pass all the multicast traffic through. Ether switches typically only isolate unicast traffic, and you can get Ethernet to run at a variety of relatively high speeds. And so as a result, we can now do video on the Ethernet, and in fact, a number of commercial enterprises are now doing that. So broadcast video uncompressed. Well, when we look at something like video, we see CCIR 601, a standard video, which is standard definition, and it's quite a large stream, 160 megabits per second uncompressed. So it seems to me like some kind of compression is going to be needed, even with today's standard very high speed rates. So when we think about what video is, we know that it includes both image sequences and audio. It includes screen captures, which are generally over noise, almost noise-free, but it also includes things like camera frames, which come in with tons of noise. But if we have a screen capture, well, what we have is the ability to exploit what's known as inter-frame coherence as well as intra-frame coherence. That is, the pixels within the frame are very similar to the pixels that are next to them. So, for example, here we see large areas of white with a few areas of black. And so we can code this relatively efficiently during the transmission. So typically when we look at the socket API, we see sockets and server sockets, but when we look at multicast, we have a separate socket known as the multicast socket. And what that does is it receives and transmits multicast socket datagrams, and the datagrams are connectionless. So that means we can simply push them out to our network without regard for whether or not they're being received. So in a connectionless protocol, it's roughly analogous to dropping letters in a mailbox. We don't know if anybody got them, and there's no acknowledgement unless we decide to program it into the application layer. So when we think about how we are going to go about doing this, we look at, for example, this connection.java, which allows us to make a socket, start the socket thread, proceed to run, and print out something like the date. That's typical. And when we look at a daytime server, we can see that there are these sockets which allow us to get the local host and listen for the date and time coming in. So our UDP, that's User Datagram Protocol based applications, don't use this socket technique. They don't make specific connections. Instead, they rely on we'll call it a connectionless protocol, which is typically unreliable. It has some advantages. It requires that we be tolerant to the fact that we may or may not have reliable communications, but it also allows us to go very quickly. We don't have to stop and wait for acknowledgments, and we can have a message-oriented service. The datagrams for containing our data typically are small. Once they get too large, things will not work properly. And the question of how you're going to pack the data and make it useful in a small packet is really application specific. Your datagram packet is an array of bytes, and something that is listening for the datagram packet has to know how to decode the bytes, which means it has to know what to expect when the bytes come in. The datagram socket is a class that is representing a mechanism for sending and receiving datagram packets. Address information for outgoing packets is contained in the header. A socket is used to read the incoming packets. They must be bound to an address. Sockets that are used for sending must be bound as well, but in most cases that's done automatically. There is no special datagram server socket class. Since packets can be lost, the ability to set timeouts is important. So if packets come in very late, we may just discard them. So here comes the datagram socket API, and it gives us a port and an internet address. Typically what we're going to do is provide some sort of an example so you can see all of this stuff working. And what I've done here is I've set up a small chat facility which allows us to communicate. I'm just doing this on the local host now. Let's see if this works. Testing the local host. And so we can see that was transmitted and received over here, testing the local host. Hello, CR320, and there it is, receiving a message. Now that'll work just as well on non-local hosts, but for the purpose of this broadcast, I think it's just a little bit easier to do this from local host to local host, and certainly that's the way you would do it if you were at home, unless you had two computers. So then the question becomes, okay, how does all this work? What I have created is a small toolkit called the multicast utility, and what it does is it selects a port that you can use for transmitting your datagram packets, and it sets up an address known as a multicast address associated with those packets. So multicast addresses have been reserved, and here is an example of a multicast address. And I put that into the utils under net.multicast. So if we go back to the main, we can see there's a mechanism that asks if you want to transmit or receive. We have a chat main and a transmitter for chat. And in the chat main, we have a streaming audio multicast receiver, so we can do audio as well, which is kind of neat. And we can also find a way to do video if we like. But we're constrained a little bit by the size of our of the datagram packets that we can use. So let's get back to this chat main. Here we are in port 1234, just made up a port for the multicast utility. We've created JInfo frame, which is going to give us the ability to type something into the API. And then what we do in here is we enable loopback so we can see what we've typed ourselves to ourselves. And then we're going to process with our multicast socket. Here what we'll do is we'll create a chat receiver. And the chat receiver has got a little run text field in it. And whenever somebody hits enter, it takes the text information and then sends a line out to the multicast stream. And if we call open, it'll send a file. If we say open sir, it'll send a serialized file or an instance. Otherwise, it just takes the string that comes in and it calls mcx.sendBytes. To send a serialized instance of a file, what we're going to do is we're going to get the file as bytes and then send the bytes. That way we can send objects which are not just text. If we want to send a text file, we can get the read file in and call send a file, which is going to take the entire file in as a string and then send it out as bytes. So everything seems to depend on the MCX instance known as multicast util. And so what we'd like to know is how to send and receive bytes. So here's how we set the loopback. We just set loopback disabled or enabled. Here we can get bytes from the datagram packets. We call new datagram receive. We do call a multicast socket receive on the datagram. We get the data and then we can do something to get the data into a byte array and return it. We don't know exactly how big it'll be, so we use b.length, and that's important because rcv.getLength will come back with a datagram packet that is a length that we're not sure about until we receive it. When we want to send data, we do know the length of the data that we're going to be sending in advance because we're given it as a single array of byte. And so what we're going to do is create a datagram packet from that array, and then we're going to call multicast socket.send on the datagram packet. When you look at something like multicast socket.send, what you're seeing is a part of the Java API, the datagram socket. So that now we're really deep into the API for sending data. So our job as programmers is to pack datagrams and then send them. That's the end of it. Once they are received, someone will invoke getBytes. The datagram will come in, and the bytes will come out. And that's the long and short of how to use multicast. So when we go and run something like this, the loopback enables us to see what it is we're typing. And if we run it twice, this is the second instance, and it's seen by the other transmitter/receiver. If we run it 3 times, all 3 clients are able to be activated, and all 3 of these things can see what's going on. And if we type open, it tries to open a file for transmission. I don't happen to have one available, although, well, here's a CSV file. I suppose we could try and send that. And, oh, there it comes. There's the CSV file. So here's a whole bunch of names and addresses and phone numbers that were stored in the CSV file. And presumably they're here, and now they're here as well. So they all got transmitted to all 3 info frames, which is kind of neat. Anyway, that's my little demo. Hope you liked it. Thanks a bunch. Bye-bye.